Hello everyone, today we will see how to bivariable and multivariable Cox regression analysis. So we will see first how to bivariable Cox regression analysis and multivariable Cox regression analysis, how to perform it. Then we will see how to Cox proportional hazard assumption will be made by using Schoenfeld visual tests and graphically. So we will see this one. So now we will open the data sets of the starter. So this is example data sets, and now we can use the cancer data. So this is our data. So let me introduce the data. This is study time or duration. This is an event. 1 is died, 0 is not died or censored. Drug is dependent variable, having 3 types of drugs. 3 types. So one is placebo, 2 is treatment, 3 is also another treatment. Age is independent variable, it's continuous variable, and this is stated survival analysis. So you can also see drug. So drug is 1 to 3. 1 is placebo, 2 and 3 is different types of treatments, and the other is age is continuous variable, and died is event. So 0 and 1 is died, 1 if the patient is died. So this one. So mostly you cannot get in your data set like STD and T not this one. So to set this variable before doing bivariable and multivariable Cox regression analysis, you have to set this data sets, otherwise your command will not work. So you can see set, you can do set, and you can give duration, study time, and also comma, failure, and open brackets. Then you can your events. This is an event, so you can after setting this, then you can do, or you can apply any commands in survival analysis. It will work. So this is study time. So now we can make bivariable Cox regression analysis. So to do bivariable Cox regression analysis, you can use the command sctcox. So then you can insert this drug independent variable. Drug is independent variable, so the dependent variable is already set on this sctcox. So drug is independent variable, so you can do just like this. So drug is 0.225. But to understand which drug 1, drug 2, or drug 3, you can use an indicator. So I is an indicator, so doing just like this. So this is considered as the bivariable Cox regression analysis, because it's between the survival time and the drug. So the 1 placebo is it's constant, since it's the first variable, so it's constant. So now 2 is the treatment 1 and 3 is treatment 2. So after this, this is bivariable Cox regression analysis. This is hazard ratio, and this is its confidence interval. This is p-value, so it's significant because it's less than 0.05. So now you can take crude hazard ratio as 0.23 and 0.7. So maybe this is to interpret this one. So you can interpret so the hazard of this is decreased by 23. 1 minus 0.23, it is 77. So the hazard of this is decreased by 77%. percent in drug 2. Individuals who take in drug 2 at any given time, so at any given time as compared to their counterparts, or as compared to individuals who take placebo. So we can interpret just like this, or we can say individuals with drug 1 are we can say 77% less likely to die at any given time that of individual who take placebo, or we can interpret it just like this. So this one is 0.7, so 1 minus 0.07 is 93. So the hazard of death is decreased by 93% in individuals who take drug 3 at any given time as compared to their counterparts. So this one is bivariable. So if you wanted to change by another way, you can say you can use AB. You can use AB list. So it will use the cert. Treatment as constant. So 1 and 2 is as variable. So you can change also by just like this. Now the best thing is now we have done and interpret the bivariable Cox regression analysis. So the other one is that multivariable Cox regression analysis. So multivariable Cox regression analysis, to say multivariable, independent variables should be more than 2 and more than 2. So SCT Cox, I drug is one variable, the other is H. Since we have 2 independent variables like drug and H, we can use H. So this is number of subjects, number of failures 31, time at risk is 744. This is local likelihood. Local likelihood is minus 81. So this is minus 81. So it takes the last iteration. From minus 99 to minus 81. So it takes the last iteration. So number of observation is 48. Probability is significant, and log likelihood the chi-square is 36.52. so this is our analysis. So this is time. So hazard ratio is this. So standard error, this is significant, or both variables are. Age is significant, and also this variable is also significant. 2 categories also significant. So this is confidence interval. So this is now adjusted hazard ratio. That's why, because 2 variables, so it's multivariable Cox regression analysis, because it's 2. So you can add more than 2 variables, like 30, 20 or 10 variables. So in this way the same thing is happen. This is 18 means 82. So the hazard of death is decreased by 82% in those individuals who take drug 2 as at any given time, as compared to who take placebo or their counterparts, and 0.05. so the hazard of death is decreased by 95% in individuals who take drug 3, so as compared to their counterparts. So you can interpret in this way. Age, so in the case of age, it is positive. So since hazard ratio is greater than 1, it is risk. So as age increases, the hazard of death will increases by 1.12 times. So age increase means will provide for with quickly days, or more likely to days. So this is positively, this is negatively affects the hazard of death. So this is multivariable Cox regression analysis. Now we can see we can see how Cox proportional how to test proportional hazard assumption, both statistically and graphically, by using statistically, by using we can do by using stat pH test. So this is a stat pH test, this is statistically. So after you run multivariable Cox regression analysis, you can write a stat pH test. So test of proportional hazard assumption, this is global test, this is chi-square, so this is chi-square probability. So our finding is 0.7994. So this 0.7 is greater than 0.05. So if it is less than 0.05, our assumption will be violated. But since 0.79 is greater than 0.05, proportional hazard assumption is adequate, so or kept, it is not violated. So all proportional assumptions are made. So you can do by this way. So if your finding is greater than 0.05, so proportional hazard assumption is fitted, but below 0.05, proportional assumption is violated. So by using graphically, you can also by the way, if you want to Cox-Snell residuals, you can use predict. So you can, by doing this, you can, this is Cox-Snell residuals. Cox-Snell residuals, it's important to see goodness of fit test. We will see on another video. So you can make by this way. And as I told you, to make graphically Cox proportional hazard assumption, you can do by writing ST, survival time, pH plot, comma, strata. You can insert drag and adjust. Adjust for another variable. You can adjust for another variable, but we don't have another categorical variable, so we can insert age. So we are by adjusting age, we will see the start of drag. So age, then can write 0 x label, yes. So now, this is Cox proportional hazard assumption by using graphically. So this is lines. So now it is makes zigzag in this sense, but in real time, so if you are if this lines moving forward, moving in this downward, and if it is parallel, so proportional hazard assumption is fitted. So there is no crossed each line on this way, so it should be parallel. There should be parallel. So so you can make Cox proportional hazard graphically in this way. So you can after Cox regression analysis, you can use by using statistically this one global test. You can use this one. So or you can use you can use the graphical method, this one. So this is adjusted. So the adjustment is maybe vary from variable to variable, so it seems like just big. So now in this course we have seen how to set observable data and how to make bivariable Cox regression analysis, and how to make multivariable Cox regression analysis, and then how to test Cox proportional hazard assumption by statistically by using global test and graphically. So this is all about today's topic or analysis. So to get the next analysis or the next topic and the next videos, don't forget to subscribe, comment and like this channel. So have a nice time. Bye bye.